All right, we're going to go ahead and get started. Hello, everyone. My name is Anne Greenfield. I am the Senior Director of Stewardship and Donor Services, and I'm thrilled to welcome you this evening to our event featuring our sports product design program. A few housekeeping items before we get started. We recommend you switch your speaker view to presentation for tonight. And also for the purpose of tonight's program, the audience will be muted. But if you have questions for our speakers, and I hope that you do, please use the Q&A function at the bottom of the screen and we'll get to as many questions as possible. If you have technical or support questions, those can be submitted anytime and we have staff standing by to help you. So now it's my absolute pleasure to introduce you to tonight's guest. Susan Sokolowski is the Associate Professor and Founding Director of the UO Sports Product Design Program. Wilson Smith is an instructor in the UO Department of Product Design and Design Director at Nike. They're joined by 4 fantastic alums from the Sports Product Design Program. You can see them there, and I'll let Susan and Wilson introduce them during the presentation. So you're in for a real treat tonight. Susan and Wilson and our recent grads, thank you so much for taking the time to be with us tonight. Susan, I'll go ahead and turn it over to you.
Thank you. Thank you, Anne and Wendy and Sarah, for the opportunity to share our work tonight. And good evening to everybody. Thank you for joining us. And good evening, Wilson. It's great for you to co-host this event tonight with me. We're going to get started with you a little bit, Wilson. So you're an alumni from the University of Oregon. So tell us a little bit about your background.
Well, thank you, Susan. Oh, this is the inception right here. So, okay, I'm honored. I had the joy of graduating from the University of Oregon Architecture School in 1980. But the thing that got me there was what I think is still my favorite drawing of all time. It's called Wilsonville. I did this in 5th grade, and it kind of captures my passion. You know, I had that. I love mid-century modern, all that, you know, outer space studies and the Space Needle. And so I just saw that as the future. And so this was Wilsonville. And it really, it began part of my quest of becoming an architect as a little kid. And so this was actually, here I am at the school, and it was kind of fun trying to narrow down what you think are your favorite photos from looking back to this era. But that's my parents, and that's kind of fun for me. They came to my structures class back about, that would have been a couple years before I graduated. And so that was really fun, fun being there with them. And then also I had many great experiences afforded to me at University of Oregon. The lower 2 pictures on the left, I actually was part of Professor Janassi's trip over to Europe. So we studied out of London, and that was really cool. So those are kind of 2 of my favorite parts of my schooling there, but in particular my parents. I'd love to honor them. I know a lot of you parents understand that kind of picture. I eventually came to Nike, and so there was a shift in a sense of my architecture, and I was applying it to doing corporate architecture. And I had the great connection of being hired by Tinker Hatfield, another University of Oregon alumni who was the corporate architect. So he hired me as his assistant. So it was really fun. And back here, we were primarily doing architecture that expressed this kind of vibrant, vital, young company, which would have been now 37 years ago when I was first hired at Nike. And so we're reflecting the energy of this company. The shoes themselves didn't express quite yet, but all of the idea of the big crashing swooshes, but then all of that architecture was really transferred into product creation. And so this is what Tinker Hatfield and our team we've been working on. So that's been part of my journey, Susan. So that's pretty much my world. But Susan, why don't you tell us about your journey and how you got to University of Oregon?
Yeah, so I actually grew up out on the East Coast in New York State, and I was a Title IX athlete. And this is actually a picture of my high school soccer uniform that really has always been an inspiration point of answering the question, How can female athletes be equally outfitted as their male counterparts for sport performance? I'd say what most people don't know is that although I'm a college professor, I was actually a first generation college student. And for me, college was really a way to make a difference for myself. But also along the way, I realized that teaching was a great way for me to give back to all those that came before me and help pave my way. And I started teaching at the U of O in 2011. I was an adjunct in product design. And in 2015, I was recruited to create and direct the new sports product design MS program at the UO in Portland. And coming to the University of Oregon not only provided a platform for me to support and educate the next generation of sports product innovators, but also allowed me to conduct research and apply sport product knowledge to other fields. And so this is an example of what I mean by applying sports product knowledge to other design fields. This slide showcases a University of Oregon musical conductor and also trumpet player named Brian McWhorter. He would call himself a musical athlete. And this work shows my research utilizing 3D body scanning to understand mobility needs for a new conductor's jacket with details inspired by sport products. This slide highlights a small study that I'm currently working on with a UO data scientist named Jake Searcy, looking at deep learning of 3D body scans, especially the head, and how to develop better sizing systems for PPE masks. So Wilson, going back to you, you teach a popular class each winter in our product design BFA program called Adaptive Athletes. Can you tell everybody about that class?
Well, absolutely, Susan. The fun thing that I've had the joy of being a part of this program since its inception, where I remember when we were first meeting around the concept around 2008. And then I remember I actually started in the program teaching in about 2010. So it was always something that has been a passion, has been around product creation and around an opportunity to share that with the next generation of designers. And so in working with students, I had worked on a couple studios, and I wanted to figure out a way that we could potentially simulate some of the pleasure that I've had at Nike in terms of working directly with athletes. I know that you've experienced that as well, Susan, just that whole innovation process. And I thought, and we were brainstorming with the department head at the time, Kirsten Munchinger. We were brainstorming how could we possibly create an end user driven program where we could really serve and create for athletes. And we were initially, I was inspired by this quote. And I think we can go to this quote right here from Mr. Bill Bowerman, who is indeed the legendary track coach of University of Oregon. And he says, if you have a body, you are an athlete. He was also the co-founder of Nike with Phil Knight. But the notion of if you have a body, you're an athlete was very inspiring for my co-teacher and myself and the department head. And so we came up with this concept. So the next slide, we talked about adaptive athlete design and really having an opportunity to work with all bodies and with a group that was perhaps an underserved community, and really an opportunity to design for them and have students have hands-on engagement with athletes, with the end user. And so out of this, they could also design products and then also actually make products for them and improve the athlete's performance in sport. So it became a really exciting equation within a 10-week period of time. Both concept and making is now happening whenever we do this studio. So that's been a real fun for me. And what I'd like to do now is actually share with you some of our amazing student work. And I'm pleased to introduce to you, we have actually 2 alumni from the product design program that have been taking the class. And I want to share with you and some of what they're doing here in class and then what they did doing today. So I'm pleased to introduce you Becky Kira Canetti here. And Becky is actually going to tell us about your Adaptive Athlete program.
Hi everyone, my name is Becky Carachetti. I am a user experience researcher and designer working for Intel Labs, but prior to that, I was a student at University of Oregon. I got my BFA in product design in 2016, and tonight I'm going to talk about the project from the Adaptive Athletes course that I designed called Embrace. Susan, next. Thank you. Embrace was designed for wheelchair rugby athletes. And wheelchair rugby is a sport that's kind of like wheelchair basketball meets soccer sort of thing. You've got two teams of 4 players, and the goal is to constantly keep a volleyball moving and eventually get it in your opponent's goal. Wheelchair rugby is unique in that all of the players are quadriplegic, meaning they've got some degree of limitation in all 4 limbs. And also, which you might be able to see from the state of this guy's chair. Wait, go back. Okay, sorry. It is a full contact sport. So players will actually use their chairs to run into one another, and it's pretty common actually that players will get knocked over. Everything in this sport, with the exception of the wheelchairs themselves, are kind of repurposed from other things. So there's a lot of opportunity for us to do design. Okay, next one. I think this photo really kind of captures the problem space that I was going after. This is a piece of gear that belongs to a man named Seth McBride. He worked with us throughout the entire studio, and he was the person in the first photo. A lot of people with these sort of injuries don't necessarily have dexterity to grab wheelchair wheels in the way that we might imagine. Instead, they put these sort of big shields on the wheels, and then they kind of lean forward and drive their arms down and punch the wheels, and they use that to sprint across the court. And this is what Seth was using to protect his hands from the abrasion. This is a $3 gardening glove with some rubber taped on it. So this was the space I wanted to address. And there are a couple key learnings from doing this studio. And the first one was just sort of coming to understand the design constraints of this particular space. So obviously, if the athletes are sort of doing this really aggressive punching motion, they need to protect their arm from abrasion. And then they also need grip so that they can interact or interface with a wheelchair. And at one point, I put a shoe on my hand and I showed it to Wilson and said, I need to make a hand shoe. And that was the concept that drove all of the design work. I was also doing a lot of experimentation with the value that compression might add. Oftentimes, these athletes have somewhat limited muscular function in their arms, so they might be unable to use a muscle, they might have reduced strength or reduced range of motion. So, just trying to experiment with what compression, maybe a little bit of extra tension or resistance might add to the functionality. And then finally, a very common issue with spinal cord injuries is that the athletes lose the ability to thermoregulate. So the body can't heat and cool itself properly. So while I was trying to give them protection and structure, I was also trying to reduce material from the product. And then the next thing that was really, really critical is that as somebody who was able-bodied and at the time not particularly athletic, it was really difficult for me to imagine what these athletes might be experiencing. So it was absolutely foundational to take the design hypotheses that we developed and to manifest them somehow. So this is a selection of the couple of prototypes that I made, mostly the more photogenic ones. There are a lot more. And we were super lucky in that Seth was coming to our class multiple times over the course of the term. So he gave us feedback on our design work. And we were also had access to the Portland wheelchair rugby team. So everything that's on the screen here, I had multiple people try on and give me feedback. And it's absolutely crucial to reach out to your user in that way and make things real when their experience is so far outside of your own. Final slide, thank you. So this is Embrace in its finished form. The final product ended up being a 3-finger glove that goes up to about the deltoid. You can see there's some perforation in there and some windows, which is to aid with the ventilation. There's this sort of rubber shield that goes along the bottom of the forearm, again for that grip and abrasion protection. It's scored along the axes of movement so that it does not inhibit the athlete. And the other thing that I discovered in the course of having people try and put these things on is that getting geared up is a pretty big challenge, and athletes often need a lot of assistance. So there are many features in here to try to give them back a little bit of independence. So we did away with the 5-finger glove design because they don't necessarily need that dexterity, and it's very difficult to sort of wiggle fingers into a 5-finger glove. All of the closure mechanisms on there are made with rather big grips. So again, you don't need that really fine dexterity so that you can do it with a couple fingers or a hand or even a mouth, which was very common. And then finally, there's some reinforcement in the upper cuff so that people could pull it up with their mouth, which again was a very common adaptation that these athletes made. So this was Embrace.
Awesome, Becky. You know, and just one thing that I thought was great was Seth was also a part of the 2016, you know, at least going towards the Olympics. At least there was an opportunity for that, and I believe this became as an inspiration toward those, so that whole Olympic move at the time, which was very great. But since then, Becky, I was wondering, you know, this is such great work that you've been doing. What have you done since graduating from the program?
So I am now a user experience researcher and designer. I'm working in Intel in the R&D section of the company, so I'm in the labs. And what we do is we work alongside engineers to develop sort of the technology of the future. And what they do is figure out how stuff works, and we figure out the human side, so why it works, what people want from it, so the metrics of what they need, the sort of values that they have, and how those values should be reflected in products that will someday hit the market.
That's outstanding. And yes, I see the connection with all of your great detail work here. So thank you very much, Becky. That was outstanding. And next I want to introduce another one of our designers, Zach Meyer. He's also here to present his work from the class. And Zach, why don't you tell us about your adaptive athlete project?
Hey, Wilson, thank you. I'm Zach Meyer, and I was in the 2018 iteration of this class. And in that class, I met and worked with John Cunningham, who's pictured there. And he unfortunately lost his right arm to an IED blast in Iraq while serving as a Marine back in 2005. On the first night of that class, he brought with him his prosthetic setup, which as someone in his position, he had been given every single prosthetic that was available on the market at the time that his incident happened. And what he chose to use is this setup here. And it's actually what most every arm amputee that can afford and chooses to use a prosthetic also uses. And the system is just comprised of a simple 1-inch wide webbing harness, a carbon fiber socket or a plastic socket. That's a little bit cheaper option. And those are just patterned off of a plaster casting of the user's arm. A terminal device, the most common one is surprisingly this, what's called the Hosmer hook. And that was patented back in 1918 and has not changed much since then, as we see. But it's really a utilitarian device that can grab tools and all these terminal devices, you can sort of choose whatever you like. There's an individual one for every single sport you could imagine. There are cosmetic hands. The hook just happens to be sort of the most utilitarian and widely chosen. But all these work on just a simple premise that you extend your arm and you put tension on a cable, which opens that device. And then when you release tension on the cable, the device closes. So really simple function, but it helps users that are missing a limb do various two-handed tasks that otherwise wouldn't be doable. And the reason that this system is what's chosen most frequently is just that it's a really easy on-off device for when you really need something. But otherwise, a lot of one-handed users choose to get by more frequently without any prosthetic at all, just because of how poorly considered these products are for the human-facing factors. And that was sort of what I immediately noticed the opportunity was. You can go to the next slide, Susan. So going back, you know, the Portland Design Museum was running an exhibit back in 2018 that was called Bespoke Bodies, and it was all about design for adaptive people, prosthetics in particular. So they had a full history that I got to go look at and study of arm development in the US. And I saw around World War II, there was a clear parallel between, you know, early sporting equipment and prosthetic design and manufacturing. And for obvious reasons, after World War II, sports products exploded and became what we now see it to be today, and prosthetics sort of stagnated. And I saw an opportunity as, you know, how do we sort of reimagine prosthetics today, given all of the development that we've been afforded through the market size and sort of the drive for innovation in sports products. John sort of relates the current state of the art in prosthetics to a Dutch wooden shoe made out of carbon fiber. If we were to look at shoes following the same trajectory of innovation. So in this project, the goal was, think about footwear and think about athletic materials and how we could combine sort of a structure with lacing and a textile component to create a prosthetic that allows breathability and more moisture management for the user, as well as improved range of motion. So early sketches went through all of those ideas. The harness was a focus as well, in that by simply widening the straps and creating a harness that was actually shaped around a human body, you could better disperse the load and mitigate a lot of the nerve damage that happens after a lifetime of use with one of those simple harnesses. Similar to Becky, this project relates to the human body in motion, and in particular, a single individual human body that sort of changes for every single patient. So luckily with U of O's equipment, we were able to, early on in the term, 3D scan John's arm at various positions and be able to understand how that volume shifts and moves throughout the range of motion. And with that, I was able to start designing various structures around that in CAD without John having to be there, so that he could come back and I would have a full set of prototypes ready to go through with him, and really see how any ideas of a structure and a lacing system combined together could work for him. So luckily I had 20 weeks to work through this project. And so I was really able to tackle both the arm and the harness as individual design projects all through really heavy iteration. And here's where we were at the end of those 2 terms. So the harness itself is inspired by the Arc'teryx climate harness, in that it's this really reduced, thin stack up of materials that helps transport moisture away from the body, and it remains breathable through perforations. And then the BOA lacing system allows the user to, with one hand, make on the fly really small adjustments. So say you're doing a lighter load activity, you could run the whole system a little bit looser. And if you were going to go pick up groceries, you could tighten it up a little bit more for a heavier load. And really the sort of the key thing in all this was the program's focus on prototyping and iteration, which I sort of see as really unique to the U of O, in that they push everyone to really try and make a physical idea, so that you can have it in front of you and get more efficacy testing than you would just a drawing or a rendering of that. So yeah, really fun project.
Wow, Zach, it's really an outstanding project, and your work here is also going to be featured in that Portland Design Museum book from their Bespoke Bodies exhibit that you referenced earlier. So that's pretty exciting. Yeah, well, you have been about to take also this project that you just showed us. You're about to take it into a place and doing a lot more. And so could you tell us what has happened since you graduated?
Yes, yeah. So John, as an engineer and a Marine and an amputee, is very active in trying to push for development in the space of prosthetics. And he's got both a nonprofit called Open Prosthetics, which helps compile development that's happening around the world in the prosthetic space, so that everyone can sort of be aware of what everyone else is working on. And then he's also got a prosthetic development company, and both of those companies I've now had the opportunity to have employment and funding through to continue this work now for the last 2 years. So I've had a prototyping and design role with them, and I guess to a certain degree a custom prosthetic fabrication role. So yeah, we get to work with clinics around the world. One of the largest out in Jaipur, India, that I've gotten to travel to now, which was super fun back when travel was a thing. And we work with Walter Reed in DC, and then individually with individual patients that are interested, we can sort of work with a clinic near them to get a 3D scan and send it our way for a prototype. So yeah, I've gotten to continue this work for 2 years now.
It's so exciting to move that forward, Zach. Well, Susan, you've also been focusing on products for underserved populations in the graduate program. So tell us about that work.
Yeah, so the sports product design program brought in its first cohort in 2016. So in comparison to other programs at the University of Oregon, we're still quite new, and many folks may have not even heard about us yet. But since we're a master's degree program focusing on design, our annual cohort is quite small. So we accept up to 20 students a year, and we're a master's degree program. And within this model, because we're small, it allows students the ability to spend time with faculty, take on research projects, and have their own studio space. We're located in the beautiful White Stag building in downtown Portland. And our studios are actually right below the Portland, Oregon sign. And so it's really nice to be able to call out that that's our location downtown. And we're really fortunate to reside in a space where actually the largest sports company of its time operated. What you may not know is up until the mid-1900s, the White Stag brand was actually the largest sports company in the country. The mission of the Sports Product Design program is to develop graduates proficient in using scientific theories and creative problem-solving methods to design products that push the boundaries in sports. And these boundaries extend to the types of athletes we design for. When most people think of sports product design, they may think of elite athletes that may compete in the Olympics, the World Cup, the NBA. And what we're really curious about are all athletes in our program, especially athletes that haven't been studied for or designed for yet. And our students have not only been designing products for astronauts and aging bodies, but they're also designing for COVID. And so we wanted to share with you what our environment looks like this term and how we're working through a slightly different setting because of the pandemic. And our students are socially distanced in studios. They have access from 7 a.m. to 7 p.m. And they're learning under a hybrid model of remote and in-person education. So tonight we have two alums from the Sports Product Design program that will present their thesis research projects on the design of products for underserved athletes. And I'm pleased to introduce you to Chrissy Betancourt, who will present first.
Thanks, Susan. So as Susan said, my name is Chrissy Betancourt. I graduated in June of 2020 from the Sports Product Design program. I'm a footwear designer and developer with a bachelor's degree in engineering and human-centered design from Dartmouth College. And before attending the Sports Product Design program, I was a footwear designer for the kids' shoe brand called Play, based in San Francisco. I'm also an avid runner. Oh, not yet. I'm also an avid runner, and my goal as a designer is to create running shoes that enable more people to run and feel as included as I do in the running community. So I'm presenting a brief snippet of my capstone project called Anybody, which is a size-inclusive footwear collection. So I was inspired to work on this project by ultra runner Myrna Valerio, who's pictured here, and she says about running, anybody can do it. She's an incredible athlete who runs races up to 120 miles. And I was able to work with her on this project, which was really incredible. So 65% of women in the US wear plus sizes, and yet most running brands still cater to the elite athlete, this thin, idealized version of what you think of as a runner. Anybody champions the runners who don't fit that mold, the runners who were told they're too fat to run and did it anyways. So through my research with athletes, I determined that my three main problems to solve are fit, underfoot cushioning, and aesthetic appearance. So fit is a concern since a lot of plus size women often have fuller, flatter feet or fallen arches. And tight fitting shoes are also very hard to get on if you have a thick foot or a high instep. Carrying more weight than the so-called average runner results in increased stress on the bones and skin of the feet, as well as the shoes, resulting in shoes that break down too quickly. So women were reporting their shoes breaking down after 150 miles rather than the typical 300 or 400. Shoes designed to the specificity of an elite athlete's body do not immediately translate over to athletes of all body sizes. And finally, while running shoes tend to be bright and bold, when you filter by width, all you get are black and white, but women still want shoes that are fast, fun, and sleek. my process for this work began with lots of research. So the University of Oregon allows us to travel for our projects, which is really amazing. So I did research trips both to go visit Myrna in New York City, as well as to Boston and the UK to research last making. So the last is the form around which a shoe is made, and it greatly impacts the fit and feel of the shoe. So I really wanted to dive in and learn about it. So I got to attend the last making workshop in the Eastbourne, UK, where I was able to bring these 3D printed feet that I was able to make based on the 3D printed, the 3D scanned feet of one of my athletes. I also used sketching to explore how the lines of the shoe could be used to make the shoes look fast, especially considering the shape of the last. While I was initially exploring some asymmetrical designs, some early feedback from athletes indicated that it was important that the shoes looked like other running shoes, since some women might not feel comfortable wearing something that looks so drastically different than what other runners are wearing. I also used prototyping as a method of ideation, since the construction and pattern making were so important to the success of the product. Went through tons of prototypes, working through the construction details, fit and proportion, and then revising based on athlete feedback. And then, as Susan mentioned about adapting to COVID, I also had to troubleshoot the prototyping process itself as I converted to my at-home studio setup at the beginning of the stay-at-home order. So I no longer had access to the lab. Initially, we were not allowed to go to the studio. And so I had to figure out how to make shoes at home in my apartment with just a domestic sewing machine. So that was a challenge on its own. So I made works like prototypes for fit validation. I focused on making sure that the shoes accommodated a wide range of foot shapes and allow the foot to move while still feeling secure. So since I couldn't meet up with my athlete, I had to mail them to her, and we had a Zoom session where we reviewed the prototypes and had her try them on, get some feedback. She said she really liked the fit and said they felt secure and comfortable, supportive, without feeling too snug or causing any irritation. So overall, Anybody's shoes were designed from the ground up for plus size women. They have a spacious, comfortable fit with a wide opening for easy entry and a system of support and cushioning features that are meant to move with the foot and absorb impact without wearing out too quickly.
Thanks, Chrissy. That was a really great presentation. And I think the work is so important and really helps push the footwear industry into a new space that I think a lot of folks haven't done yet. So what have you done since this project?
Well, so I've been working with Susan, through some research with the University of Oregon. So Susan and I worked together throughout the last year in school, and then I was able to continue the work over the summer. So we've been doing a lot of work focused on plus size apparel fit and sizing, as well as the sort of like naming conventions surrounding that. So looking at the future of marketing communications surrounding body shape and fit. And as well as we've also been working on a traction project looking at reducing slips and falls for aging demographics.
Thanks, Chrissy.
Thanks, Susan.
Our last presenter today is Sarah Clucker. Sarah, tell us about your Adaptive Athletes project.
Hi, so as Susan said, my name is Sarah Clucker, and I'm a 2020 graduate of the University of Oregon Sports Product Design program. I came to the program with an undergraduate degree in apparel design from the University of Minnesota, where I also ran on the women's cross country and track team. I also come from a family of elite runners with Olympic appearances and American records in the pedigree. So I have strong ties to the elite running community. And I really wanted my thesis project to play into that, as well as connecting to my why of getting into sports product design, which is to help anyone and everyone experience kind of the wonderful things about sports that I have been able to. Which brings me to my thesis project, which is the Velux collection. It's a collection of apparel and racing gloves designed for elite women's wheelchair racing athletes for Tokyo 2021. All right, next slide. So pre-pandemic, I was lucky enough to travel to Champaign, Illinois, where many of the women who represent the US on the Paralympic wheelchair racing team live and train under the coach Adam Bleakney. There I met the athlete Susanna Scaroni, who will be representing the US in Tokyo in the marathon, as well as several of her teammates who informed me of all the shortcomings in the sports apparel world when it comes to apparel for wheelchair racing athletes, and especially or specifically in regards to the apparel that they are issued for at the Paralympic Games. So this was one quote that I took. Ian Huang, who is one of the athletes I talked with, she was talking about the uniforms they were issued for Rio 2021, and talking about the aero blades, which were designed for these uniforms to make standing track athletes more aerodynamic and faster. But for the wheelchair racing athletes, it meant that they couldn't get into their racing chairs with these leggings that they were provided. This was one of many issues, from fit to mobility to graphic visibility, that were issues with the current uniforms. But it really all comes down to them being issued apparel and uniforms that are not optimized for their sport. Next slide. So for my project, I chose to look at creating a collection of products for the Paralympic Games. And I started with uniforms and racing gloves. And then after talking with athletes, I decided to approach weatherproof training apparel as well, because of the many pain points that athletes discussed. Many of the athletes brought up Boston 2018, which had historically wet and rainy conditions, where they ended up having to tape trash bags beneath their long sleeve shirts to keep themselves dry, because traditional jackets do not allow enough shoulder mobility for them to compete. So I wanted to leverage my own running background and biomechanic knowledge to inform the designs, as well as direct feedback from athletes. Next slide. So I started with lots of sketching, and sending those back and forth to athletes to get feedbacks. And then I went through with prototyping. And at this point, we had entered pandemic. And so initially, I had planned to travel back and forth to Illinois several times with my travel budget. But I ended up doing a virtual fitting with Susanna. I sent her my sort of like fitting prototypes, and then she was able to wear test them and give me feedback. My travel budget then got funneled into creating a home studio in my parents' basement in Minnesota, so that I could create my final prototypes. Next slide. And so this is the uniform and the racing gloves, so sort of the competition side of the apparel. It's ergonomically designed for the position that the athlete's in while they're competing. It features a protective silhouette so that athletes don't chafe against the racing chair, and then positioning informed graphics, because in the uniform that athletes are issued now, designed for standing track athletes, you can't actually see the national identifiers while the athletes are competing, and then ventilation informed by the athlete positioning as well. And then the glove on the lower left corner, that is the racing glove that I designed for biomechanic assistance to limit tendon injuries in the wrist. All right, next slide. And this is the weatherproof apparel, where I really wanted to look at mobility. That was the biggest issue that athletes faced with traditional jackets. Gore-Tex was kind enough to provide materials, and so I was able to use stretch paneling of weatherproof material in order to create a jacket that far outperformed any jackets on the market for wheelchair racing. And as well as I created leggings and then a thermally protective glove that interfaces with the 3D printed glove that athletes use to race in. And that's my project. Thank you.
Thanks, Sarah. That's great. I think what's so cool about your project is that you got to work with this great athlete, right? Like Paralympic athlete. And I think your knowledge in apparel like really translated so well for these athletes. And it was so fun to see that process of you even working remotely and doing fittings with them over Zoom. I think that it's just so great to see how our students are using technology to get the work done. So what have you been up to, Sarah, since graduation?
So I have been on a few different contract roles. Most recently, I started on with Target Corporation. So in my hometown, Minneapolis, Minnesota, I'm working on their performance brand, designing kids apparel. So yeah, that's been the most recent project I've been on.
That's great. Thank you so much, Sarah. And with that, I really want to thank Sarah, Chrissy, Zach, and Becky for sharing their amazing work with us tonight. And Wilson, thank you so much for co-hosting.
Indeed, an honor, Susan. Yeah, I was very, very inspired by your work and by this work, and especially for serving athletes who maybe aren't typically, served. So it's fantastic.
Yeah, I think it's so important. And I think if the audience, if you're ever interested in supporting our students, you can connect with us at either one of these email addresses at pdinfo@uoregon.edu or sportsproductdesign@uoregon.edu. And with that, we'll take if there's any questions.
So thank you all so much for your wonderful presentation. Your guys' work is so inspiring. And we do have a question that I am going to pose to the panel. Susan and Wilson, maybe we'll start with you and then you can work through your students. So the question is, how has empathy inspired your work?
That's a wonderful question. Maybe I'll do a little bit of a macro take on it. I feel that empathy is a motivator, and and even studying it, even with your in brain studies, that when you are challenged with a responding empathetically, you have to make a choice to either respond extravagantly and help, or to ignore. And so I think it's really great. Empathy becomes a great motivator for student work. And I know for these 4 students exhibited here, and the 2 that I particularly worked closely with, and Becky and Zach, they did extraordinary work in a single term, and that has extended and continue to play in their whole career. So I think the empathy plays such a huge role, and I'm sure that you guys can all speak to that in different ways.
Yeah, I'll speak a little bit, and then maybe each of the students can talk about their experience with empathy in their projects. But I think when we design products for athletes, and most of us who design products for athletes were athletes at some time, or were connected to sport some way because we really loved watching them, or we knew somebody that was an athlete. So we already are bringing like our own personal empathy into the kind of the project. And then I think what's so lovely about designing for athletes is that everybody has a story about how they connect with product, and sports products are they're very emotive. And so people, are connected to color, people are connected to fit, people are connected to the product that they won a competition in. And so getting, understanding kind of the psychology and the connection of athletes to products is so important in the work. And it's just a really lovely process to be involved with. But I would actually ask, let's ask each of the students. Maybe we'll start with Becky and go down through all the presenters and ask them what they think about how empathy played a role in your project.
It's funny that you mentioned that, most of us come from a place of sport, or at least watching sport, because I actually completely didn't at all. But that was one of the things I learned during the term, actually, that was just really actually had a pretty big impact on my personal life outside of school, but also my professional life. Just witnessing this incredible drive to do things that was present in the athletes. And especially when you consider, I think a lot of us think that being quadriplegic would be a huge challenge and what might stop you from doing a lot of things. And it was just incredible watching these unstoppable athletes. Like I said, Seth was competing globally in wheelchair rugby. And in my career now, my job is empathy. Our job is to take these really neat futuristic things that the engineers are working on and try and understand what people want from that, and understand people's values, and understand people's feelings about those things, and how these technologies fit into their life and impact their life, not just on a practical level, what opportunities do we have to be more meaningful, to be emotionally significant to you. And then we take that information And like, we kind of, it almost feels like an honor to be the people who were partial to that, and then, take it back to the company. And so we use empathy to drive technology that was being developed. So it's a pretty significant portion of what I do, and one of possibly the biggest learnings coming out of the program for me.
Thanks, Becky. How about you, Zach?
Yeah, I was just going to say something pretty similar to Wilson in that for me and likely most designers, empathy is a bit of a motivator. I think empathy is kind of it's both like a really hard part for some people to master in the design process. I think there is some sort of realm of design that doesn't need as much empathy, but I think that empathy, when it's used, for example, you can use empathy to maybe pull insights out of what a user might want without that user needing to say it explicitly. And if you were to then deliver a design to them that answers those unspoken wants and desires through that empathetic lens, like that's really where design success can come in. So it's a motivator, it's a tool. And yeah, it's definitely a driving inspiration for me.
How about you, Chrissy?
So for me, I think one of the things that I struggled with a little bit at the beginning of the process was that I am not a plus size athlete, and I was trying to work on this project. And so I talking with some of these athletes, I asked them, is it a problem that I'm working on this? And they adamantly said, no, it's very clear that you're coming at this from such an empathetic lens and really wanting to get more people involved in this sport. And so I think that as long as you're approaching it from the right angle, like being able to relate to these athletes can be really powerful.
Thank you, Chrissy. How about you, Sarah?
Yeah, kind of bouncing a little bit off of what Chrissy has said, I think empathy is definitely, like, I feel like it elevates your design from just designing more product to designing product for somebody specific and having it be really meaningful. And I think being able to empathize with athletes and people who don't share your same exact life experience, like that's what makes you a good designer. Like if you can only design for people like yourself, you aren't going to make it very far. And so being able to pull from your own experience, but then really listen to and feel for the problems that different athletes are facing, and be able to answer to sort of those unspoken wants and needs. I know within my own project, it was really interesting because when I initially approached the project, the athletes weren't super forthcoming with saying that there was a lot of problems with the apparel and product that they had, because they were so used to just problem solving on their own and dealing with issues that came up. And, me approaching the project as a runner who has had all kinds of product designed for people like me, it was crazy. I was like, oh my goodness, like how can you put up with this? And so I wanted to bring like a little bit of the experience of having like beautifully tailored product designed for me, like to a user group who doesn't necessarily have all of those options. And so I think that was one way that empathy like played into my project a little bit, was having to tease out kind of what problems to solve a little bit when it wasn't initially apparent.
Thank you, Sarah.
Great. Thank you, you guys. Another couple of questions. We'll try to get to them all. So this one is for the students. Can you guys, and maybe go in the same order and quickly mention how you all connected with your athletes and adaptive users? How did those partnerships start?
Do you mean like if in our case, I think, Wilson, that you guys had probably like contacted Seth ahead of time because he was there on like the first day. And then through him, we were introduced to the wider Portland team of wheelchair rugby players. And then we could just, establish contact ourselves and talk to people that way.
Great.
I might just, and I mean, no, I would love to hear from others, but I was going to echo what Becky said. The athletes in these communities are very open and enjoy this engage and this opportunity, and it's fun to work that way. So not only do the students connect, but they seem to expand their relationships generally.
Thank you. All right, I think with that, this concludes our program. Susan, Wilson, Becky, Sarah, Zach, and Chrissy, thank you so much for taking the time tonight. Your work is amazing and inspiring, and we appreciate you spending an hour with us. Thank you, everybody, and have a lovely evening. Good night.
Thank you.
Thanks, guys.
Thank you.